Okay, so we were just talking about how we would find the equation of line CD. Well, we already got the slope, right? Earlier on we said that the slope was -2, and so that means that we've got y equals -2x plus some unknown b value. So if we can just find that by substituting in either point C or point D, both of which are on line CD, I'm going to use point C. So my x value is -2 and my y value is 1. So x is -2 and y is 1. And then that will enable us to show that 1 is equal to 4 plus b, and so we'll figure out that b is equal to -3, and the equation of the line then would be y equals, well, here's your slope, -2, and x, and then your b value is -3. However, it tells us to put it in the form ax plus by equals c. In other words, it wants the a and the b to be on the left-hand side, the x and the y terms on the left. Let's bring the -2x to the left. It becomes a positive 2x. And then we've still got the -3 on the right. Let's just check to see whether we did abide by the conditions. Are a, b, and c, okay, these coefficients, are they all integers? Yes, they are. 2, 1, and -3. So I'm finished at this stage. Now it says find the coordinates of E. This is where the lines A, B, and C, D intersect. So I guess I'm going to need to not only have the equation, oh, they gave us the equation of the line AB, and we've got the equation of the line CD, so we should just be able to find their intersection. Let's do that with polysimilt. So apps, and we'll go to polysimilt, and we'll go to the simultaneous equation solver, and we'll say next, and let's put in these new values. So our first coefficients are 2, 1, -3, and our second equation has been given to us with 1, 3, 6 as the coefficients. 1, 3, 6. And let's solve. We'll find that they intersect when x is equal to -3 and when y is equal to +3. Lastly, we need to find the distance between points A and D, so that's just going to be an application of the distance formula. So let's just remind ourselves what A and D were. So we need to take the difference between the x coordinates, that's going to be 3 minus -1, and we need to square that difference. And then we also need to find the difference between the y coordinates and square it. So A and D, we've got 1 and -1. Let's find that difference. So 1 minus -1. So we'll simplify. We're now taking the square root of 3 plus 1 squared, which is 4 squared. And this is 1 plus 1 squared, that's 2 squared. That gives us the square root of 16 plus 4, and so we've got the square root of 20, and if we wanted, we could put this into the calculator and figure out what the square root of 20 is, and round it to 3 significant figures, that's the IB convention, and we get approximately 4.47. Onwards to number 10. So we've got the point 23 and another point 49. We need to find the gradient between them. Well, we know how to do gradient. It's the difference in the y coordinates divided by the difference in the x coordinates, and that gives you a gradient of 3. Then we need to find the gradient of a line that's perpendicular. Well, we know that that's just the negative reciprocal. And part C, they give us the equation of a line and say that it's perpendicular to the line segment. In other words, this line, its slope, will be the same as the slope that we just found because they're both perpendicular to segment AB. Well, we know then that the slope of this line must be -1/3. I'm going to rewrite this equation in a different form. Let's try to put it into slope-intercept form, which means that the y has been isolated. So by, as I start to isolate my y, I'll bring my 2x to the right, it becomes a -2x, and I'll bring my 12 to the right, it becomes a +12. And let's get the y alone. So that means dividing everything through by b. We have to divide the first term by b and the second term by b, everything divided through by b. Now look, this is the slope of the perpendicular line, and this is the slope of the line, which we've been told also is perpendicular. So because these lines are both perpendicular to AB, they must both have the same slope. So negative 1 over 3 must be equal to negative 2 over b. Alright, let's cross multiply then. So b times negative 1 gives me negative b, and 3 times negative 2 gives me negative 6, and you'll discover then that b is equal to positive 6. Question 11. Here's the graph of this function. We need to write down the domain. Now remember, with domain we're going to be squishing it down to the x-axis. So imagine if I squished this graph down to the x-axis, what x values would it cover? Well, it would cover everything from 0 through to the end of the graph, which is at 450 degrees. And so your domain then will be 0 is less than or equal to x is less than or equal to 450. I suppose we could put degrees in here if we're fussy about units. So there's your domain, all of your possible x values. And what's the range? Well, now we're squishing everything over to the y-axis. So I squish over these values to the y-axis and these ones over to the y-axis and squish everything over to the y-axis, including these. Oh, that gives me the same. Oh, look, I've already been here. I've already covered these values on the y-axis. I end up discovering that I've covered everything between 1 and 5, and that will be your range. Everything between 1, I've screwed up, didn't I? I said everything between 1 and 5. And because it's a range, then we have to use the variable y instead of x that we use for the domain. Number 12, we've got the line PQ. We've been given its equation, and it intercepts at P and Q. It wants us to find the coordinates of P and Q. Well, we've done a few of these already. We know that the y-intercept occurs when x is 0. And so 2y is 12, and so y is 6, but it wants the coordinates of p, so 0, 6. Let's do the same thing now. This is a place where y is equal to 0 at the x-intercept. Let's substitute in then a y value of 0, and this means that x plus 0 equals 12, and so your coordinates of point Q, an x value of 12 and a y value of 0. Part B, we've got the second line with that equation, which intersects the line PQ at point A. So in other words, we've got this equation, and we've got this equation. We want to find out where they intersect. Well, this is going to be a time then to use polysimult, so that we can find the intersection, or the solution of this system of simultaneous equations. And so we'll put in our first coefficients of the first equation, 1, 2, 12. And we'll put in the equation, the coefficients of the second one, 1, negative 1, 3. And then we'll press the solve button, and it tells us that the x value for point A is 6, and the y value is 3. Number 13. The midpoint M of the line between A and B has got coordinates 2, 3. So this time it's given us the midpoint, and we've got to figure out what the values of S and T are. Well, we know that our midpoint is equal to the average of the x coordinates, that's S and negative 2, and the average of the y coordinates, which is 8 and T. So obviously, this x-coordinate of the midpoint is equal to this x-coordinate of the midpoint. So let's see if we can solve that equation. It says that 2 is equal to s minus 2 over 2, right? Plus negative is like a minus. So let's bring the 2 up to this side. So 4 is equal to s minus 2, and we'll figure out then that s is equal to 6. Same thing for the y-coordinates, that 3 is equal to 8 plus t over 2. Let's bring the 2 up to this side, multiply both sides by 2, then it becomes 6 equals 8 plus t, and we'll discover then that t is equal to negative 2. Part B says find the equation of the straight line perpendicular to AB, which passes through point M. Alright, well, we better find the slope between A and B first, and then the perpendicular line, its slope will be a negative reciprocal. And so we're now dealing with, we know that s is equal to 6, so we're dealing with the point 6, comma 8, and we're dealing with -2, comma -2. So let's find the slope between these two coordinates. So slope, it's the difference in the y's divided by the difference between the x's. Make sure you keep the same order. That gives me 10 over 8, which is 5 over 4. The perpendicular slope then is going to be the negative reciprocal, which is -4/5. Now that's only given me the slope. I've also know a point that it goes through. So I'll say y is equal to, here's my slope, and my unknown y-intercept at this stage. Let's substitute in our known point of 2, comma 3. So my y is 3, and it's equal to -4/5 of my x-coordinate 2. And this is like a 2 over 1, which will help me multiply those fractions. So I've got then 3 is equal to -8 over 5 plus b. To get b alone, I'm going to have to bring the -8 over 5 to the left, where it will become a positive 8 over 5. And let's get some common denominator. 3 is the same thing as 15 over 5, right? It's an equivalent expression, because 15 divided by 5 equals 3. Just multiply the top and the bottom by 5. And I can add 15 and 8 over 5. That gives me 23 over 5. And so the equation of the line then will be y is equal to -4/5 x plus 23 over 5. Number 14. There we've got the equation of the line L2. It tells us that this L2 is y equals x. And it doesn't tell us what the equation of L1 is, but we should be able to figure it out quickly. The gradient, let's start with the gradient. We've got a point on the line which is 0, comma 2. We've got another point on L1 which is 6, comma 0. The gradient between them is going to be the difference in the y coordinates divided by the difference in the x coordinates. That's 2 over -6 or -1 over 3. And so that's the gradient of L1. And the equation, so we know that this is our gradient. We've got to figure out what the b value is. So let's substitute in, oh actually the b value appears right here, doesn't it? And so we can see that the equation is this one. And then to find the area of the shaded triangle, we know that area of a triangle is 1/2 times base times height. In order to find this height, we'd like to know what the y-coordinate is, because this is the distance from the x-axis, right? That y-coordinate will show us how high that point is above your horizontal base. So to find that, let's put in both of these equations into, this time I'm going to do it a little bit differently. Okay, I'm going to go into y equals, and I'm going to put in my first equation, which is L1, -1/3 x plus 2. So -1/3 x plus 2. And my second equation, y equals x. And let's find the intersection of them. There's my first one. And there's my second one. You can see the little triangle in here. Now I guess I could adjust my window so that it ends up looking more like what we've got here, going from, say, 0 out to 6, and my y values go from, say, 0 out to 2. And if I regraph, we'll end up getting something that looks a lot more like my diagram. There's the first line, L1, and there's L2. And if I can find the intersection point, then I'll know the height of the triangle. So we'll say second, calc, and go down to option 5 to get the intersection. Is this my first curve, y1? Yes. There's my second curve, y2 equals x, yes. And I guess, looks like they intersect around x equals 1. Turns out that actually they intersect where x is 1.5 and y is 1.5. But it's the y value that I'm interested in, so this distance must be 1.5, and I can see that my base is 6, and so area is 1/2 times my base times my height, and that will give you an answer of 4.5.